All right, so today we are looking at elasticity and its applications. We looked at demand and supply. Today we want to look at the elasticity of demand and supply and then the applications of these concepts. All right, so basically, these are the questions that we'll be trying to answer in this video. The first question is, what exactly is elasticity? So when we talk about elasticity of the demand, what do we mean? If we talk about elasticity of supply, what exactly are we talking about? Then what kinds of issues can elasticity help us to understand? So after knowing the concept of elasticity, what can the idea, the knowledge that we get help us to actually understand in economics? And then what is price elasticity of demand? And then how is it related to the normal demand curve? And then how is it related to revenue and expenditure? So we'll try to answer all these questions. Then we move on to the elasticity of supply. So what is price elasticity of supply? And then how is price elasticity of supply related to the supply curve? And then we look at the two other types of elasticity, the income and then the cross price elasticities of demand. So these are the questions that we'll be trying to answer in this video. All right, let's look at a scenario. Assuming you are a website designer, you design websites for local businesses, and then whenever you design one website, you charge $200, and then currently at a price of $200, you are producing 12 websites per month. But then you realize that the cost of creating the websites is increasing. So you are considering whether to increase the price of the website or not. So you want to increase the price of the website from $200 to $250 per website. So when you do this, we know from the law of demand that whenever there's an increase in price, we should expect a reduction in quantity demanded or the quantity that you'll be able to sell. So now, because you are increasing the price from 200 to 250, we expect that you are going to sell fewer websites. So because the price has gone up, what is the quantity that the consumers are going to reduce? I mean, if they were initially buying 12, are they actually going to reduce the quantity that they buy? And then how much will your revenue fall when you increase the price from 12 and from 200 to 250? And then there's a reduction in the quantity demanded from 12 to whatever quantity that the consumers will now buy. How does that affect your total revenue? Is the total revenue going to increase? Is it actually going to fall? So we can answer all these when we have an idea about the elasticity of demand for the price elasticity of demand for your website. So let's start with the basic idea of what elasticity is. Now, when you talk about elasticity, we are talking about how one variable responds to changes in another variable. So we have two variables, assuming X and Y. So we want to measure how changes in X will affect the quantity of Y. In other words, how will Y respond whenever there are changes in the variable X? So when we talk about elasticity of demand, then we are talking about how quantity demanded will respond to changes in price. So here the two variables are quantity demanded and then the price of the commodity. So price elasticity of demand means that how will quantity demand respond whenever there are changes in price? In other words, how do consumers respond to changes in price in terms of the quantity that they buy, okay, in terms of the quantity that they buy. So elasticity is a numerical measure of the responsiveness of quantity demanded or quantity supply. So here we are talking about both elasticity of demand and elasticity of supply. So elasticity is a numerical measure of the responsiveness of either quantity demanded or quantity supply to one of its determinants. That's why we have types of elasticity. So when we are talking about price elasticity of demand, then we are looking at the numerical measure of the responsiveness of quantity demanded to changes in price. We can talk about income elasticity of demand. So that one we are looking at the numerical measure of the responsiveness of quantity demanded to changes in the consumer's income. Okay, so in terms of numbers, that is what elasticity actually measures. Right, so the formula for finding price elasticity of demand is the percentage change in quantity demanded divided by the percentage change in price. Okay, percentage change in quantity demanded divided by percentage change in price. So it just measures how much quantity demanded will respond whenever there is a change in price. Okay, whenever there's a change in price. So in other words, we can say that price elasticity of demand measures the price sensitivity of buyers or consumers to demand. So whenever there are changes in price, how sensitive will the consumers be? How do they respond in terms of the quantities that they buy? So that is what price elasticity of demand measures. And the formula is given by percentage change in quantity demanded over percentage change in price. Let's look at an example. Now, we know this to be a normal demand curve. So the vertical axis measures price and then the horizontal measures the quantity demanded. Initially, price was P1 and quantity demanded was K1. Now there's an increase in price from P1 to P2, assuming the increase in price is 10%. Now, per the law of demand, whenever there's an increase in price, we expect a reduction in quantity demanded. So, assuming quantity demanded falls from K1 to Q2, and that is a 15% fall. Then, for you to get a price elasticity of demand, this will be the percentage change in quantity demanded, which is 15%, divided by the percentage change in price, which is 10%. So, we are having 1.5. Okay, so percentage change in quantity, which is 15%, over percentage change in price, which is 10%. So we have a price elasticity of demand of 1.5. Okay, 1. So this is just an example of how to find the elasticity. Now, we know that with a normal demand curve, the law of demand, whenever there's an increase in price, we expect a reduction in quantity demanded. And whenever there's a reduction in price, we expect an increase in quantity demanded. So they move in opposite directions. Okay, they move in. If one is moving up, the other one is expected to move down. Okay, the other one is expected to move down. Okay, so now because they are moving in opposite directions, whenever there's an increase in one, there's a decrease in the other. So calculating price elasticity of the demand will always give us a negative number. Okay, a negative coefficient. But here we'll just drop this negative sign and then report all the elasticities as positive numbers. We can do this because we know that definitely whenever you measure price elasticity of demand, the answer should always be negative. So if you see the elasticity coefficients not having negative signs, it doesn't matter. We know they do have negative signs. Okay. Right now, when you want to calculate the percentage change in a particular variable, it's just the end value. That's the new the new one minus the old one divided by the old value times 100%. So the end value minus the start value over the start value times 100%. So if you look at this example here, okay, assuming that point A was the initial point, and then point B is now the new point. Then in terms of price, the old price was 200 and the new price is 250. So if you want to calculate the percentage change in price here, is the end value, the new value, which is 250, minus the old value, which is 200, divided by the old value, which is 200. So we have 250 minus 200 over 200. This should give us 50 over 200. That is 25%. So this is how we calculate the percentage change. Okay, this is how we calculate the percentage change. Now you can do same for the quantity. Okay, for quantity, if we are moving from A to B, then the percentage change in quantity demanded is going to be 8 minus 12 divided by 12 times 100%. Okay, and that is giving us 33%. So if we want to calculate the elasticity of demand, the price elasticity of demand, if we move from A to B, or if price increases from 200 to 250, Then we have 33% over 25%. That is giving us 1.33. Okay, that is the price elasticity. Now, the issue is that if we are using this formula, the coefficient, the price elasticity coefficient that we get depends on the direction that we are moving, whether we are moving from A to B or we are moving from B to A. This elasticity here is when we moved from A to B. Now, if we have to move from B to A, then the percentage change in price is going to be 200 minus 250 over 250. Okay, 200 is not the new price minus the old price of 250 over the old price of 250. That will give us 20%. So price would have fallen by 20%. Now, if you take the quantity, we are moving from B to A. So now 12 is the new one. So we have 12. The percentage change in quantity demanded will be 12 minus 8 divided by 12 times 100. That will give us 50%. So based on this direction, moving from B to A, the elasticity coefficient will be given as 50% over 20%, and that will be 2.5. So you see that when we move from A to B, we had a different answer. And then when we move from B to A, we are having a different answer. Okay, that is why we use something called the midpoint method. The midpoint method. So the only difference is that after you found a difference between the end value and then the start value, we don't divide it by the start value. We divide it by the midpoint or the average of the end value and then the start value. So we just add the two values and you divide it by 2. That will be the denominator. But the previous one, the denominator was just the start value. That is what was causing the differences in the coefficients based on the direction that we move. So here, after finding the difference between the end value and the start value, then you add the 2, we divide it by 2. That will give you the midpoint, which will serve as the denominator here. So let's look at this now. Assuming we are moving from 200 to 250, so from A to B. Now the difference between the end value and then the start value will be 250 minus 200. But the denominator, instead of writing 200, we find the average of 250 and 200. So add 250 to 200. Okay, that should give us 450. If you divide it by 2, you are getting 225. So now the denominator is no longer the start value, but the midpoint. So this is giving us 22.2%. Then for the quantity 2, after finding the difference, 12 minus 8, we find the average. 12 plus 8 is 20, over 2 is 10. That one is giving us 40%. So the price elasticity of demand becomes 40% divided by 22.2. That is 1.8. Now, when you use the midpoint formula, it doesn't matter the direction. Whether you are moving from A to B or you are moving from B to A, you still get the same price elasticity of demand. So it's always good to use the midpoint, or by using that one, it doesn't really matter the direction of change, you still get the same answer. But unless the question specifies that you have to use the midpoint, you just check the direction of change that was given in the question and just use the percentage formula. Okay. All right. Now we want to move on to the determinants of price elasticity of demand. So what determines price elasticity? Okay, what determines price elasticity? Now, this is what we want to do. For us to understand the determinants of price elasticity, we are assuming 2 goods. We'll be comparing 2 goods. Okay, and by the comparison, we'll be able to know how a particular factor will affect the price elasticity of any of those goods. So these are the assumptions. We are dealing with 2 goods here. Now we suppose that the price of both goods rise by 20%. So good A and good B, they've all seen an increase in price of 20%. Now the good for which QD falls the most, in percentage wise, will have the highest price elasticity of demand. So we have 2 goods. The price of both goods have increased by 20%. So we are comparing 2 goods. The good whose quantity demanded in percentage terms falls by a wider margin is going to be the good with the highest price elasticity of demand. Then we look at why. Why exactly are we saying that? Then we look at the lesson that those two examples will teach us about the determinants of price elasticity of demand. So let's walk through the assumption again. We have two goods. The price of both goods have increased by 20%. So for us to know which good is more price elastic, we look for the good that will fall most, in percentage terms. Okay, so the good whose percentage change in quantity demanded will be highest, will be the good with the highest price elasticity of demand. Then we'll look at the lesson that teaches us about the determinants of price elasticity of demand. So let's take these two goods: breakfast cereal and then sunscreen. Okay, breakfast cereal and then sunscreen. Now, the first assumption is that for both goods, the prices have increased by 20%. So now, if you compare these two goods, which one will have the greatest drop in quantity demanded? Now, if you take breakfast cereal, it has substitutes. Okay, it has a lot of substitutes. If you don't take the cereal, you can take pancakes, you can take leftover pizza. Like there are quite a number of other foods that you can take as breakfast, apart from taking a cereal. So whenever there's an increase in price, now there's an increase in price of 20. So because it has substitutes, a lot of buyers will stop buying breakfast cereal and then they go and buy the other substitutes. Okay, so what is happening here? Because the price of the good has increased by 20, the quantity demand here will fall by a wider margin because it has substitutes. If you talk about sunscreen, they don't have much substitutes. So even if there's an increase in the price, it doesn't really affect the demand much. But for breakfast cereal, because it has a lot of substitutes, as soon as you increase price by even a small percentage, you will see a greater drop in quantity demanded. Okay, so here, when the price of both cereal, breakfast cereal and then sunscreen increased by 20%, then the percentage drop in quantity demanded for cereal will be higher than that of sunscreen, all because breakfast cereal has more substitutes than sunscreen. So what is the lesson here? So what we can say is that because the percentage change in quantity demanded for cereal will be higher, then the breakfast cereal has the highest price elasticity of demand. So the lesson is that price elasticity is higher when we have substitutes, when the good has substitutes. Okay, so if the good doesn't have substitutes, then a change in price will result in a very small percentage change in quantity demanded. That will make the good inelastic. But if the good has substitutes, then a small change in price will cause a larger percentage change in quantity demanded, making the good more elastic. Okay. Then let's look at blue jeans, and then this entire clothing. Okay. Now, if you take jeans, this one too, we are assuming that there's a 20% increase in price. Okay, for both goods. If you take jeans has a lot of substitutes. If I don't wear jeans, I can wear shorts, I can wear khaki. You see that jeans is narrowly defined. Okay, but for this, it is broadly defined. If you talk about it, we have a lot of things under this good. Okay, a lot. The khakis are there, the shorts are there, the speedos are there, jeans, material. All those things are part of this. And if you take this as a whole, it's almost like it has no substitute. Okay, it has no substitute. But if you take jeans, jeans is narrowly defined, and as a result, it has a lot of substitutes. So jeans will tend to have a higher price elasticity. So price elasticity is higher for narrowly defined goods than for broadly defined ones. Let me give you another example. If you take milk, if you just say milk is broadly defined, and milk doesn't really have substitutes. But if I talk about Ideal milk has a lot of substitutes. There's Popular, there's Kanishi, there's Peak, and all those ones. So when you narrowly define a good, it tends to have a lot of substitutes, and as a result, it becomes more elastic than a broadly defined good. So that is another determinant for price elasticity. And then insulin and then Caribbean cruises. For insulin, all those diabetic patients depend on it. Their lives depend on it. So even if there's an increase in price, it doesn't matter. They still have to buy it, but they see it as a necessity. So they still have to buy. So even if price changes by 20%, the percentage change in quantity demanded will be very low. Okay, it will be low. Price has increased by 20%, but the fall in quantity demanded will be lower than 20%. That will make the good inelastic because it's a necessity. But if you take cruises, this is a luxury and people can do without them. So as soon as price increases by 20%, the fall in quantity demanded will be more than 20%. So it will make that good more elastic. So the lesson is that price elasticity is higher for luxuries than for necessities. If you take something like salt is a necessity. So you can't say that now there's an increase in price of salt, and as a result, when you are cooking, you won't put salt in your food. No, you still have to. But if you take something like phones, should the price of phones be too high, people won't buy it. It's a luxury. We can do without phones, but we can't do without water. We can't do without salt. So it doesn't matter where the price goes. We still have to buy them. Okay. So necessities do have inelastic demand, and then luxuries do have elastic demand. And then the demand for goods in the short run versus the long run. So gasoline in the short run versus gasoline in the long run. Now there's an increase in price of gasoline by 20%. Now in the long run, in the short run, people cannot actually change their cars that use gasoline. In the short run, you wouldn't be able to actually respond to the change in price. All right, so whenever there's an increase in the price of a good in the short run, consumers are unable to actually respond. Okay, they cannot really respond to the changes in price, but the longer the time period, the more time they get to make decisions. You see that whenever there's a change in price, there's a change in incentive. So to respond to it, you need time to think about it. So now, if you use the example of this gasoline, in the short run, you can't say that you won't take a bus. You still have to take a bus. So you still have to pay for this increase in price. But in the long run, people can choose to use other smaller cars that doesn't really consume much gasoline, or they can even make sure that their houses are nearer to where they work so that they wouldn't have to buy any fuel at all. Okay, so if this is the case, in the short run, whenever there's an increase in price, you are unable to actually reduce your quantity demanded by a greater percentage. You can't actually change it, but in the long run, you can actually respond. So demand for the good becomes inelastic in the short run and more elastic in the long run. Okay, so the lesson is that price elasticity is higher in the long run than in the short run. Okay, than in the short run. All right, so this is a summary of the determinants of price elasticity. First, you need to consider the availability of substitutes. If the good has substitutes, it tends to be more elastic than goods that do not have substitutes. And then you check the nature of the good. Is it a necessity or a luxury? If it's a luxury, it becomes more elastic than necessities. And then whether the good is broadly defined or narrowly defined. If it's narrowly defined, it becomes more elastic. And then the time horizon. Elasticity is higher in the long run than in the short run. So these are the determinants of price elasticity of demand. All right, now we move on to the variety of demand curves. Okay, the variety of demand curves. Now, if you take the price elasticity of demand, it's quite related to the slope of the demand curve. Okay, now the general rule is that if the curve is steep, if the demand curve is steep, then it means that the price elasticity is very small. So demand becomes inelastic. But as the demand curve becomes flatter, then the elasticity becomes bigger. So we have higher price elasticity of demand on flatter demand curves, but then smaller or lower elasticity of demand on steeper demand curves. Okay, so let's look at the 5 types of demand curves. Now we have the perfectly inelastic demand. This is one of the 2 extreme cases that we have. Perfectly inelastic demand. Let's look at the diagram. It is a vertical demand curve. What this means is that quantity demanded do not respond to changes in price. Even if price changes, you still demand K1. So here there can be a percentage change in price, assuming the percentage change in price is 10%. There is no percentage change in quantity demanded, because quantity demanded does not change. It's always at K1. So the percentage change there is 0. So graphically, it is vertical. And then numerically, the price elasticity of demand for perfectly inelastic demand curve is 0, because there is no change in the quantity demanded. So the demand curve is vertical. For consumers' price sensitivity, there is none at all, because they do not respond to changes in price, and then the elasticity coefficient is 0. So this is one form. That's a perfectly inelastic demand. Then we have inelastic demand. Okay, inelastic demand. Here they become a bit responsive to changes in price, but not much. So even if there's a change in price, there's actually going to be a change in quantity demanded, but the percentage change in quantity demanded will be lower than the percentage change in price. So numerically, the percentage change in quantity demanded, assuming the percentage change in price is 10%, then that of the change in quantity demanded will be lower than 10. So your answer will be lower than 1 or less than 1. Okay. So whenever you calculate for price elasticity and then your answer is less than 1, maybe 0 point something. Okay. If it's like that, then it means the good has inelastic demand. Okay. So the demand curve is relatively steep. Okay. And then for consumers' price sensitivity, it is relatively low. Though we have some level of sensitivity, it is low. And then numerically, the coefficient is less than 1. Okay, so that is inelastic demand. Let's look at unitary elastic demand. Here, the percentage change in price is exactly the same as the percentage change in quantity demanded. So if price is changing by 10%, then quantity demanded is also changing by 10%. So the elasticity coefficient is exactly 1. Okay, graphically, you see that the percentage, the change in price here is exactly the same as the change in price. So if P falls by 10%, then K will rise by 10%. So the demand curve is, it has an intermediate slope. Okay, for consumers' price sensitivity, it is intermediate. And then for elasticity, it's exactly 1. So whenever you calculate for price elasticity of demand, then you get exactly 1. It means that we have a unit elastic demand. Okay, a unit elastic demand. Okay, then let's look at elastic demand. Elastic demand. For elastic demand, here the percentage change in quantity demanded is greater than the percentage change in price. So if price is changing by 10%, then quantity demanded will change by something greater than 10%. So your answer will be greater than 1%. It will be greater than 1. Okay, so it's going to be greater than 1. So if you look at the curve, you see that the curve is becoming flatter. Okay, because the percentage change in quantity is greater than that of the change in price. So the demand curve is relatively flat. And then for consumers' price sensitivity, it is relatively high. Okay, they are very responsive to changes in price, and the elasticity coefficient is greater than 1. The last one is perfectly elastic demand, the other extreme case. This one, it is horizontal to the quantity axis. Here, price doesn't change, but quantity demanded can just be varying. So the consumers will be buying different quantities at the same price. Okay, at the same price. Price doesn't change at all. So numerically, the change in price is 0. Percentage change in price is 0. But then the change in quantity can be any percentage at all. So the numerical value is infinity. So here the demand curve is horizontal. When you come to the price sensitivity, it's extreme. The consumers are extremely sensitive to changes in price. Okay, and then numerically the coefficient is infinity. So when you calculate for price elasticity and you get a very large number, it means the good has a perfectly elastic demand. Okay. All right, elasticity of a linear demand curve. Now, if you take the linear demand curve, the slope of the curve doesn't change. It's constant throughout, but the elasticity isn't constant. Demand for the good is more elastic at the top here and less elastic at the down here. So if you get to the middle, the midpoint of the linear demand curve, you get a unitary elastic demand. So as you are moving down from the top to the bottom, there's a reduction in the sensitivity of the consumer. In other words, the demand for the good becomes less elastic. Okay, becomes less elastic. All right, now we want to look at the relationship between price elasticity and total revenue. Now, let's go back to the scenario that we used. We said that the person wanted to increase the price from $200 to $250. So what is going to happen to revenue? Is revenue going to increase? Is it going to fall? Now, we know that revenue is price times quantity. Okay, your total revenue is the price that you charge for your commodity times the quantity that you sell. Now, whenever you increase your price, it has two effects on the total revenue. And the reason is that when you increase price, it affects the revenue. But because of the law of demand, there's also going to be a reduction in quantity demanded, which will also affect revenue. So let's look at these two effects. Now, when you increase price from 200 to 250, it means that you'll be getting more revenue on each unit that you sell. Initially, it was just 200, now you are getting 250. But because of the increase in price, you have to sell fewer units. That's a lower kill. The quantity demanded for your good is going to fall. And this is because of the law of demand. Okay, so now, after the increase in price, whether revenue is going to increase or decrease will depend on these two effects, the magnitudes of these effects. If the effect of the increase in price is higher than that of the reduction in quantity, then your revenue is going to increase. But this depends on the price elasticity of demand. Okay, this depends on the price elasticity of demand. So we want to compare or look at how, or the relationship between total revenue and then the price elasticity of demand. Now, we know that price elasticity of demand is percentage change in quantity demanded over percentage change in price. And total revenue is price times what? Times quantity. So let's look at the case where demand is elastic. How does a change in price affect the total revenue? Now, let's remind ourselves that demand being elastic means that the percentage change in quantity demanded is greater than the percentage change in price. Okay, the percentage change in quantity demanded is greater than the percentage change in price. So what this means is that if you increase price, then the fall in revenue resulting from the reduction in quantity will be greater than the increase in the revenue resulting from the increase in price. Now, you've increased price from 200 to 250. The increase in price is causing an increase in revenue, but the reduction in quantity is causing a reduction in revenue. And for elastic demand, the percentage change in quantity is greater than the percentage change in price, which means that the fall in revenue as a result of the lower kill will be greater than the increase in revenue as a result of the increase in price. Okay, so what this means is that total revenue is going to fall whenever the demand is elastic. When demand is elastic, then increase in price will cause a higher reduction in revenue as a result of the lower kill than the increase in revenue as a result of the increase in P. So let's look at this example. Now, we are assuming the demand is elastic. Per the scenario, the demand was, price of the demand was 1.8. Now, initially, price was 200. Quantity demanded was 12. Let's calculate total revenue. It's price times quantity. 200 times 12 will be 2,400. Good. Now, if you increase price to 250, the demand is now 8. Quantity demanded is 8. So 8 times 250 is what? 2,000. You see that there's a reduction in total revenue from 2,400 to 2,000. So whenever demand is elastic, a price increase will cause revenue to fall. Okay, if you look at the diagram here, The yellow shaded portion is an increase in revenue as a result of the increase in price from 200 to 250. Then this part is the reduction in total revenue as a result of a lower Q. And you can see that this portion is greater than this. So there's going to be a fall in total revenue. Okay, there's going to be a fall in total revenue. All right, so let's look at the second scenario where the demand for the good is inelastic. So inelastic demand means that the percentage change in quantity demanded is less than the percentage change in price. Okay, so now what this means is that whenever you increase price, the fall in revenue from the lower Q is smaller than the increase in revenue from the higher P. So this means that your total revenue is going to increase. The demand is inelastic. So the percentage change in price will be greater than the percentage change in quantity demanded. And know that whenever you increase price, that one is causing an increase in revenue. And then the reduction in quantity is causing a reduction in revenue. So if the percentage change in price is higher than the percentage change in quantity, then it means that there's going to be an increase in the total revenue whenever you increase price. So what this means is that, now let's look at the example. Now, when price was 200, quantity demanded was 12, total revenue was 2,400. Now, price is 250, okay? Price is 250, and then the quantity demanded is now 10. Total revenue here will be 250 times 10. 250 times 10 is 2,500. You see that it's greater than 2,400. So what this means is that because demand is inelastic here, if you calculate the price that's your demand, you get 0.82. 0.82. So you getting 0.82 means that the demand for this good is inelastic, and that's the reason why an increase in price from 200 to 250 is causing an increase in total revenue from 2,400 to 2,500. Okay, so when demand is inelastic, a price increase will cause revenue to rise. So, for example, you are selling your own good. Okay, you are selling your own good, and then you realize that the demand for your good is inelastic. Then what should you do? If you want to get more profits, you increase. All right, sorry, I had a disruption in my network. So now, because the demand for the good is inelastic, okay, we had 0.82 if you calculate this. Now, when price increase from 200 to 250, there's an increase in revenue from 2,400 to 2,500. So, assuming you are a firm, you are selling your good, you want to increase your revenue, you need to know the elasticity of demand for your good. If the demand is inelastic, then increasing price will increase your revenue. But if you know that the demand for the good is elastic, then what you have to do is that if you want to increase revenue, don't increase price. If you increase price, your revenue will fall. So rather reduce price so that your revenue will increase. So knowing the elasticity for your good is very, very important. It helps your pricing policy. Okay, it helps your pricing policy. All right. We look at price elasticity of supply. Okay, this one is just the percentage change in quantity supplied over percentage change in price. It's just as the demand, but here we are talking about producers or sellers. So price elasticity of supply, it measures how much quantity supply responds to changes in price. Okay, in other words, it is trying to measure sellers' price sensitivity. How sensitive are sellers to changes in price? Okay, so here too, we can use the midpoint method to compute the percentage changes. Okay, now let's be using the midpoint, since that one will give us an accurate answer irrespective of the direction. So let's just be using the midpoint. Now let's look at an example. Here, there's a normal supply curve. Price increases by 8%. Quantity supplied increases by 16%. So if you want to get the price elasticity of supply, that would be 16% over 8%. That would be 2.0. Okay, 2.0. So this is your supply, the price elasticity of supply efficient. Now we look at the variety of supply curves. Now, the slope of the supply curve is also related to the price elasticity of supply. It's just like the demand. The flatter the curve, the bigger the price elasticity of supply. And the steeper the curve, the smaller the price elasticity of supply. So here too, we have 5 types. It's just basically like the demand one. So for perfectly inelastic, the curve is vertical, which means that the percentage change in quantity is 0. So the whole elasticity thing is going to be 0. The curve is vertical. There's no sensitivity. Even if price changes, the sellers want to respond. So the elasticity coefficient is 0. Okay. Then we have inelastic supply. Here the percentage change in price is greater than that of the percentage change in quantity demanded. So as we saw on the demand, the elasticity will be less than 1. The curve is relatively steep. Then the sensitivity is low, is relatively low. Okay, though now they respond, it is very low. Numerically, the elasticity is less than 1. Then we have the unit elastic, the same percentage change. So if price changes by 10%, quantity demanded will also change by 10%. So the numerical value is 1. The curve is intermediately sloped. And then for sensitivity too is intermediate. Okay. Then we go to elastic supply curve. Now for this one, the percentage change in quantity is greater than the percentage change in price. So here the numerical value will be greater than 1. If price changes by 10%, quantity demanded will change by something more than 10%. So the numerical value will be greater than 1. So the supply curve is relatively flat. And then for sensitivity is relatively high. Okay. Then the last one is the perfectly elastic. This one, sensitivity is very high, very extreme, because price is constant, but then quantity supply can change by any quantity or any percentage at all. So the numerical value is infinity. The curve is horizontal. Okay, for sensitivity, very extreme, very, very extreme. Then for the determinants of supply elasticity. Okay, now for supply, if you want to know how sellers respond to changes in price, what you need to know is that whenever the producers or the sellers are able to change their quantity, whenever there's a change in price, if they can easily change their quantities, then it means that the price elasticity there is going to be high. But in the case where they are unable to easily change their quantities, even if there's a change in price, that makes the supply quite inelastic. Okay, quite inelastic. So if you take a housing and maybe building of cars, I mean, we can build cars at a faster rate than building houses. Okay, so it means that the supply elasticity for cars will be higher than that of the supply elasticity of buildings, because we can easily vary the quantity of buildings that we have. And also in terms of the long run and the short run, now supply tends to be more elastic in the long run, because the firms are able to vary all their inputs. They can get new machines and all that, and even new firms can also enter the market, so that there's an increase in the quantity. So supply elasticity tends to be more elastic in the long run than in the short run. Okay, than in the short run. So now, if you look at this. Now, this part, we can take this part as a short run. Here, they just started. So as they just started producing, whenever there's even a small change in price, you see that they are able to respond much. Here, price increase from $3 to $4. Quantity supplied increase from 100 to 200. There's 100% increase. So it makes supply more elastic. So the coefficient is greater than 1. But as they are getting to, I mean, if they produce over time, here we are in the long run, the very long run. Here is like they are almost up to the limit, the capacity that their machines can produce. So if they get there, assuming your machine can produce up to 600, now you're almost producing 600. So even if there are changes in price, though you will respond, the response won't be much. So by here, because of a limit on the capacity of the firms, machines and factories and all that, they are unable to actually respond. Okay, so there the supply becomes less elastic. Okay. All right, these are the other elasticities. We have income elasticity of the demand. This one is about how quantity demanded respond to changes in the consumer's income. So if the consumer's income should change, how do they respond to changes in price? So mathematically, it's percentage change in quantity demanded over percentage change in income. Yeah, these are the interpretation. The coefficient can be positive, it can be negative. You can even get a zero coefficient. Now, if you calculate for income elasticity of the demand and the answer is positive, it means that whenever there's an increase in income, there's an increase in quantity demanded. That is a normal good. Remember definition of normal goods. Whenever there's an increase in income and there's an increase in quantity demanded, it means the good is a normal good. Okay. And then if the coefficient is negative, it means the good is an inferior good. What it means is that whenever there's an increase in income, there's a reduction in the quantity demanded. And if the elasticity is zero, it means that the good is a necessity. It doesn't matter your income level, you still consume the same quantity. So quantity demanded does not respond to changes in income. If you take something like salt, you can't say that now you have a lot of money, so you eat a lot of salt. No, it's not rational. Okay, so that's the interpretation of income elasticity of demand. Then we have cross price elasticity of demand. There's one to look at how the demand for one good responds to changes in price in the other good. So you have two goods. Now we have good one and good two. We want to look at how the quantity demanded for good one responds to changes in price of good two. So this one, the formula is percentage change in quantity demanded for good one over percentage change in the price of good two. Price elasticity 2 can be greater than 0, can be less than 0, or it can be 0. If it's greater than 0, then it means that whenever there's an increase in the price of good 2, there's an increase in the demand for good 1. So this, we say that the goods are substitutes. When the price of one increases, the demand for the other will go up. And then if it's negative, the goods are complement. Whenever there's an increase in the price of one, there's a reduction in the demand for the other. Okay. But if it's 0, if the cross price elasticity of demand is 0, it means that the goods are unrelated. There's no relationship between the two. Something like pen and kinky, they have nothing to do with each other. So the cross price elasticity of demand is going to be 0. Okay. All right, so this is where we will end. Thank you.